Now that we've got our Pump It Up project structure in place, and notice I'm in this folder in my Anaconda prompt. I've got my AAP conda environment already activated. And so what we're going to do now is we're going to take a look at this dataprep IPyNB notebook. And I don't want to spend tons of time on dataprep in this class. But I mean, it's critically important, and we will end up doing a bunch of it. But I just want to kind of point out a few things, and I'm going to make some simplifying assumptions to move on because we've got. I'm going to focus more on kind of some more advanced modeling things in this module. All right, so Jupyter Lab is open, and we'll see we've got a Py file and a IPyNB. I'll talk about this at the end of the notebook actually. And notice there's these two HTML files. We'll talk about these. I'm not going to run the automated EDA stuff in here. We'll take a look at these the outputs instead. There's a bit of trickiness with some of these packages. So, all right. So, like I said, we're going to do a little bit of data prep. It's not meant to be totally comprehensive, but definitely I'm going to hit some highlights and some things I want to do is, a quick review of reading in raw data files in pandas, and then talk about some automated EDA packages. If you've had the PCDA class with me recently, we've used Skimmer in R, and there's some similar packages for doing automated EDA in Python, and these are really nice. There's no sense recreating the wheel on some of this stuff. We'll do a little bit of manual stuff, some data type conversions and variable droppings, and then this data set's got quite a few categorical or factor type fields. And so back in R, we use the forcats package for doing factor lumping, where you can create another category that's a conglomeration of a bunch of categories that have small values, which can end up helping you in the modeling phase. So, all right, so let's move on. So first of all, and again, some of this is going to be some new stuff. We're going to eventually, be taking a look at this .py file, and we will often have, kind of parallel efforts that we'll have a notebook open and we'll have a script open. We might be storing custom functions in a Python script that we want to then import and use here. And the tricky thing is that once you import a module within a Jupyter session, it's imported. So even if you went ahead and made changes to that module and even did a re-import, it's not going to work. So the way to get around that is there's a package called auto reload, and so what we'll do is by running these magic commands, this will set the auto reload level to 2, which basically means that hey, if an imported module changes, then reload it so it can detect file changes. All right, so let's do our standard NumPy, pandas, matplotlib. I'll import Seaborn in case we want to do some Seaborn plotting, and then do our magic command %matplotlib in line so that we get our plots in line inside the notebook. All right, so the first thing we're doing is we're going to read the raw data and train X and train Y into pandas data frames, and then I'm going to merge them into a single data frame with just while we're doing EDA. So again, being careful kind of file paths. Again, we always use relative file paths, and even though I'm working in Windows, notice I always use Linux style file paths with forward slashes. Just makes everything portable. This will work just fine in Windows. And notice I'm reading stuff out of the raw subfolder. So we'll go ahead. In fact, actually, you know what? I should let's clear all the outputs. I don't know if that actually did anything to these. All right, so we're fine there, just to make sure. All right, so we'll go ahead and read these in, and there's an ID column that we can do a join on, and so now I've got them. And so we can do our kind of standard stuff. We can do an info, and we see we've got just under 40 fields, 39 fields, a lot of objects, which we know then are strings, a couple ints, the floats are actually latitude and longitude. We parse the date here. I said parse dates. So this is a date time. If you want to look at the Y value, it's the Y. It's got the ID field in the status group. That's the what we're going to be predicting. And then I combined them both, and now we're just seeing that the status group's been added there. And it looks like we've got, just under 60,000 records. If you want to kind of, peek into the data a little bit, you could do some panda slicing with iLoc and things like that. All right. So, certainly our goal is going to be to get rid of some of these columns. So sometimes it's really handy. This is a good technique is create a list of your columns. And then we can kind of use this list as a way to kind of keep or not keep certain columns. So the traindf.columns, just this part will return an index whose values are the column names. And then if you do this toList method, you'll get a nice list of column names. And so there they all are. So it's just a list of strings. So like, for example, some simple things like this date recorded and recorded by are going to be irrelevant for this model. So let's say we want to get rid of them. So what we're going to do is get rid of them from the list. Right now this thing is called calls to keep, and we'll kind of keep whittling away at calls to keep. So one thing we could do is there actually is a remove method. So I could actually put to remove a single element, I could say calls to keep dot remove and pass in. But if I've got multiple, often it's faster. What I'll do is I'll just start creating a to drop list, and I'll kind of build up a list of things to drop, and then eventually when I'm ready, I'll do a list comprehension and say, hey, calls to keep is now. I'll just do a basically loop through the calls to keep, and then if the column is not in to drop, then let's keep it. So then that'll put it. That'll fill the list in the list comprehension. So there's what happens, and we lose our, the two columns we didn't want. All right, so on to some automated EDA. Like I said, back in R, we use Skimmer. I did a little digging. If you want to check out some of the other tools I find, you can follow that link. But two that have, that are pretty nice are Pandas Profiling and SweetViz. And Pandas Profiling's been around for a while, and it's they keep improving it. You can check out the main site. I've already installed it in our AAP kind of environment. If you need to install it yourself, this is just from their installation page. Now, unfortunately, this is actually true with both of these packages, is they don't seem to play nice with Jupyter Lab. They really like the old Jupyter Notebook interface. So when I ran these, I literally, instead of starting Jupyter Lab, I started it with Jupyter Notebook, and then everything runs just fine. So if you want more details regarding installation and trying to get it to work with Jupyter Lab, you can check this out. But I just use it with Jupyter Notebook, and it's fine. So I had already kind of run this, and so this is just a screenshot of kind of from, when I had done this, just kind of showing it's, as simple as importing this library, and then you run this report, and you get this profile object, and you can barf it out to a file. And actually, one thing that we should do in our project is when we originally created our project structure, we copied in these HTML files. Really, these things feel like they should live in our output folder. They're kind of output reports. So let me drag those there. We'll put them there. Okay. So anyway, it summarizes your data set, generates a report. So again, I'm not going to run these now. But let's take a look at the Pandas profiling report. So here's the report. And it's really quite nice. It's a a little interactive web page. Gives you kind of some high level stuff. Like looks like we've got about just under 2% of missing data, how big it is, how many rows, things like that. And then it runs through each column, gives you stats, percent missing, the number of zeros, in case that ends up being relevant, a little histogram. For the categorical, you get the little, kind of sorted bar plot. So I use this to kind of try to decide, some of the things I wanted to do with dataprep. All right, so another package is called SweetViz, um, and let's check that out. And SweetViz also kind of creates these, kind of HTML-based reports. It kind of uses this tab interface. It's pretty neat. And so it's a very similar kind of thing. You have to import it, and then you run the report, and then you can show it as HTML. And so just real quick, I'll open that guy up, the SweetViz report. And there it is. Okay. It also tries to do some things with associations. You can get these, giant, correlation type matrices, and it tries to do some intelligent things with categorical data. So you can take a look through. So certainly, this can save a ton of work, and there's really no reason not to use them. They're really quite useful. So kind of from the data dictionary of the project, and then snooping the two output, reports. A couple things, that kind of pop out at you. We've got three outputs for our, our target variable, the status group, whether the well is functioning or not, or needs maintenance. Lots of non-numeric fields, lots of fields that have, zero values. We should really dig into this. Lots of, a couple of numeric fields are actually categorical. There's region code and district code. There's a bunch of fields that are kind of related in a hierarchical fashion. So you'll get things like extraction type group, and extraction type class, where this is the most aggregate. So kind of deciding what level of detail to use. And also, just a quick little manual EDA. Let's do a group by on our target variable. We'll just do the size, just kind of showing some basic pandas stuff. And also, if you want to do percent counts instead of raw counts, you can do this the dot value counts, and you set the normalize parameter to true. That normalizes it, to 100% basically is the way to think of it. So we can see that 54% of the wells are functional, 38 are not, and about 7% need repair. And you might guess already that this is probably the one that's going to be toughest to predict. As we're going to see when we're doing, both EDA and also when we're doing modeling, that we often need to be able to know which columns are numeric and which are categorical, and it helps to be able to do that programmatically. So Pandas has a select D types for select data types, and you can tell it what kind that you need, and you need to look at the documentation to know exactly what to include here. But np.number will give anything that's kind of a NumPy interpretable number. Will be true, and then we'll grab the columns and we'll fire it out to a list, so we get a list of numeric columns. So there they are. We see we don't have that many, and in fact these two, the region code and district, are really those are categorical even though they're numbers. So a couple notes about some of these things, and again, all of these really require further research, but we're going to take some shortcuts in this because I don't want to spend a ton of time on data prep, because we know in real life data prep can take a ton of time. And I was looking at this num private, and the proportions are slightly different in terms of the target variable. We could keep it around for a little bit. So let's do some data type conversions. Region code and district code, we need to convert their type to we'll convert them to categories. That's a new data type in Pandas. It's kind of similar to a factor in R. And this construction year, let's take a look at that. And it certainly does seem like the percentages are likely different by when it was constructed, so that seems like it's going to be pretty useful. So here's another way of looking at it. Pandas has a crosstab function, so we can do things like little mini pivot tables. And so you can see that kind of as you, let's see, the functionals, the top one, and certainly things that were installed later have a higher percentage, so definitely want that. And again, just kind of as a reminder, Pandas has some built-in plot functions that are just a wrapper for matplotlib, and so this is kind of useful. The functional, the functional, the blue, you can see how that ramps up as the construction year is closer to now. and the green, the non-functional, goes the other way as you'd expect, and the functional needs repair. That's going to be tough, right? All right, so that's just a little look at some of the numeric stuff. So categorical variables. When we, one nice thing about R was when we built predictive models in R, like in logistic regression, all we had to do was, if we had a categorical variable, we just included it in our formula, and R automatically created the dummies, the binary indicators. Scikit-learn is not that friendly, so we actually have to do this work ourselves. So we'll learn about variable encoders. Likewise, the R random forest package automatically handled categorical variables, whereas scikit-learn does not. So, but there are tools to do it, and we're going to be learning that more in the next session. A couple nice posts on categorical encoding are here. One from the Practical Business Python guy, Chris Moffat, is super good. So, you want to review EDA reports looking for things like, hey, are there variables I should drop because like all the values are the same? There's little or no variance in it, so it's not going to be predictive. Or are there candidates for lumping because I've got a huge number of unique values, and that's going to lead to an enormous number of variables in a predictive model, especially when we create binaries from them. And then what do you want to do about this categorical relationship? So. It's funny, as I was doing EDA, sometimes when I'm working in Python, I do find myself longing for the beauty of the R dplyr package. And so, you find yourself asking, can you do the similar kind of thing in pandas? And you kind of can. And then also just kind of in general, what are good ways to explore categorical variables? So anyway, there's a lot of kind of, interest around this. And there's a couple really, really good posts on this. And so if you're interested in diving down this rabbit hole, feel free. But I'm not going to go over it in detail in the class. So next thing I kind of looked at was the geographic variables. There's a lot of things that are geographic, and again, some of these are super detailed, down to a sub-village level, which obviously means there's going to be not many data points in there. So I kind of manually created a geography columns just to kind of quickly look at those, especially like there's 19,000 unique sub-villages, so I don't really want to include that in some predictive model. And so I started, just making decisions on, removing some individual columns. And then finally, I'm going to go ahead now that I'm going to subset my training with whatever I've got my calls to keep at this point. So I've got it down to about 34 columns at this point. But I still have lots of these hierarchical variables that I don't really want to keep, all of them around. You can see there's, 3, 4, 8 sets of hierarchical variables. So I'm just going to kind of make an executive decision and kind of keep the most aggregate of these. And again, this is certainly an area for improvement. As digging into the data prep could likely lead to better predictions. So in here, same kind of game. I'm just going to create a list of columns that I want to drop, and then play the same calls to keep, with the list comprehension, and then go ahead and resubset my data frame. So this is a pretty kind of standard technique that you'll see a lot, of people doing as they're kind of getting rid of columns. And now we're down to 24 columns, 24 predictors, because there's a column. 0 is the ID, so that's going to go away. So 23 predictors, and then our target. Right now, I'm not going to even worry. There's not that much. Some of the missing, I'm just literally going to fill it in with the word missing. That's what I'm going to do. Okay, so we're not going to focus on missing data in this class right now. And what about category lumping? So, so I'm here. Same thing. I'm going to make a list of all the string and category fields, because we know those are actually those are both categorical data. And if you run a describe on those things, right, you can start to see some of the unique counts. And some are quite reasonable and small, but others are, like funder and installer, are quite large. And even this, LGA is 125. So, but just in general, what kind of options exist in Python for doing category lumping? Like the forcats package in R. So, because maybe the funder and installer, they'll seem like they could be pretty predictive, but they've got a huge number of unique values. So I'd like to try to. So it turns out that there's a package in Python called, I'm not sure I'm saying this right, Sayuba, and it's essentially a port of dplyr to Python. So it's a port and other options. So I haven't played around a ton with it, but this same author also essentially had forcats functionality in there, and he's in the process. He or she is in the process of moving it to its own package, but right now it still lives inside there. So I'm going to go ahead and import that thing, and I'm pretty certain I've installed Saiba already as part of our AAP. And you can play this. It's got literally the functions are exactly the same as they are in R. And so I can call the fact lump function. It says, hey, take the funder column. Excuse me. And the n equals 10 is if there's less than 10 values, then let's lump that into kind of an other column. All right, so you can see there's there are lots of small values. So we've lumped 34,000 things into another column, and I could do the same thing for installer. And obviously you could play with this end value and see what you want to do. But anyway, for now I went ahead and I just did that lumping just to try to get some more more reasonable. All right, you can see we've got. Oh, I'm sorry. This n equals 10 must be the number of categories, because I've got 10 categories plus the other would give you 11. All right, so this will be kind of our final data set that we'll use for model building. Okay, so this is pretty typical. But one thing, as you're going through doing this, Jupyter Notebooks are great for doing this kind of exploratory work. I kind of would look at a plot and decide to eliminate a column. But at the end of the day, it can be inconvenient to, I don't want to really rerun all of this stuff to kind of, create my final data sets. So I kind of view this as my, prototyping scratch pad. And then when I'm, okay, I know which steps I want to do, I move those into a .py file. So into a Python script that I can just run. And so I've designed this. It's going to output both CSV files, and I was playing around with, representing data frames with JSON files. So anyway, it's going to export two different types. So I basically do a bunch of copying and pasting into just a text file, that I call dataprep.py. And in fact, I use this magic command %load to load in the dataprep.py. That's the file right there. You can actually, if I double click this, you can actually open it up into an editor, inside here. So you can kind of look at it. So this is just just the essential commands that we really needed. So now I move my imports to the top. Do my reading of the CSV files. I create a little dictionary of data frames so that I can, their key value is just the name of the variable, and then those are the variables right there. And it's just so that I can kind of create a loop where I say, hey, so let's loop over the keys in this dictionary, and that way I can just kind of use these things here. All right, so I can literally pull out which data frame am I using. I'm just going to call it DF, and it's whatever the key value is. That basically pulls out that data frame the first time through the loop, and it pulls out that data frame the second time. That way I can process things leveraging my logic inside of a loop. So I'll initialize my columns to keep. I'll drop some columns. I'll remove those geo columns. You recognize all these things were from the notebook. I didn't even really clean them up that much, other than making sure I changed the data frame names, and then kind of created my final data frame. Did some data types, did the missing data things, did my factor lumping, and then boom, fired these things out to JSON and to CSV. And notice again the kind of the use of the F string here to build up my file name. So where do I want to output it to? Well, I want to output it to the data folder, and then I'm going to be not in the raw subfolder now. I'm going to be in the main data folder because these things are pre-processed. And the name of the data frame, I can use the F string ability to use I have the little template where it'll replace this with the key value. So the first time through this will be train X, and so I'll get a train X.csv. So if I run this, and then after I run it, I'll get my there's my train X.csv and my train X.json. All right, so I just think that, again, I love Jupyter notebooks, but there's, at the end of the day, I often want a Python script version to be able to quickly run. So if something changes, I'm not like stepping through a notebook. All I do is literally run this thing, from the command line, Python space dataprep.py, and everything's done. Okay. So that'll be all we'll do for the data prep, and now we're ready to move on to the modeling, and we'll be able to use these files that were output by data prep in the modeling phase.